It's time for our second keynote speaker. I think it's not very useful to present. Everybody knows you, especially about modality. So the floor is yours. You have 1 hour.
Okay. All right. Well, first I'd like to thank Alessandro for the lovely invitation. It's a pleasure to be here. It's wonderful to be back to live, and it's been a wonderful conference. I really appreciate it. So this is part of a larger project of developing a particular form of empiricism, right? And it's sort of a way of trying to combine empiricism with modality that I think, unfortunately, empiricists have been a little too harsh against modal notions, in large part because I think they had extraordinarily narrow understanding of what experience is. So, and I think we need to think a little more broadly. And otherwise, I think it would be very difficult to keep some decent form of empiricism alive. So I'm going to do that looking at the role of modality in quantum mechanics, and then spelling out some of the consequences, right? So I think it's there's no question that modality plays an important role in quantum theory, right? Often it's invoked when we talk about the impossibility of certain quantum configurations, right? The necessity of certain radioactive decays, right? Or even the probability, right? Which is a modality with degrees, right? That's of certain experimental outcomes. Now, the question is, what's the source of that modality, right? Well, Hale has raised this issue broadly in the context of logic and metaphysics. I think exactly the same worry or concern would emerge in the context of quantum mechanics, right? So, should we explain the necessities invoked by other necessities, or should we try to explain them in terms of contingencies, right? Now, Wilson, in his lovely book, argue for the importance of a necessity-first approach, right? In a way, I think it does make sense, because to explain the necessary in terms of the contingent seems to be a non-starter, right? So, but that's exactly what I'm going to do. And of course, it'll be part of an empiricist view, and then we're going to see that we have to think about the necessity in a different way, right? Now, so, and that's what, a contingency-first approach will try to articulate, right? So what I'm doing, I'm going to identify two roles of modality in quantum mechanics, one involved in the characterization of quantum domain, in another in the specifying the states that a quantum system can be in, right? And then I'm going to offer, this form of empiricist modalism that will insist that the source of modality needs to be identifying the properties of the objects that we are considering. Now, don't get too excited when I'm talking about properties here, right? Certainly not talking about universals being instantiated, possible worlds, or anything of that sort. That would defeat the whole point of the view, right? So we need to think carefully about what these properties are, right? And then I'll sort of resist attempts to account for what that source of modality are in terms of conventions, models, or essences. None of those things, I think, actually would answer the question about what the sources of modality ultimately is. And then we'll shift to this contingency-first approach and revamp the idea. Okay, so that's the plan. So let's start with one of the two roles of modality in quantum mechanics, right? So the first one is on the characterization of what quantum mechanics ultimately is, right? And I think the very idea of what these objects are, quantum objects are, involves modality in a crucial way, right? So here's Dirac in his lovely book about the principles of quantum mechanics. And he says, quantum mechanics may be defined as the application of equations of motion to atomic particles. All right, so far so good. It looks like, at least on the surface, we need no modal notion to say what quantum mechanics is and what the subject matter that we are trying to do. But what exactly are these atomic particles, right? Now, here's something quite interesting. Dirac spent some time spelling this out. And what he offers is an account in terms of relational properties of the object's absolute size, right? And in that way, he will just completely bypass thorny issues about the constitution of such particles, right? Dirac actually was a very good empiricist, right? And he was doing some metaphysics in a way that I think is very congenial to an empiricist. So he first starts by contrasting classical and quantum mechanical explanations. He says, in a classical explanation of the constitution of matter, one would assume that to be made up of would assume matter, to be made up of a large number of small constituent parts, and one would postulate laws for the behavior of these parts, from which the laws of the matter in bulk could be deduced. All right, so far it's a fairly standard picture. This would not complete the explanation, however, since the question of the structure and stability of the constituent parts is left untouched. To go into this question, it becomes necessary to postulate that each constituent part is itself made up of smaller parts, in terms of which its behavior is to be explained. And of course, here we are sort of looming a regress, right? And so there has to be some limitation to block this kind of regress. There's clearly no end to this procedure, so that one can never arrive at the ultimate structure of matter on these lines. So long as big and small are merely relative concepts, it's no help to explain the big in terms of the small. It's therefore necessary to modify classical ideas in such a way as to give an absolute meaning of size. So now we need this absolute meaning of what the size of an object is. And if we have that, Dirac thinks we can stop this regress, right? So, and in the end, he thinks that an absolute characterization of size is needed, right? And to do that, what he does is consider the nature of observation and the fact that it requires an interaction between the observed object and some external influence. As he says, at this stage, it becomes important to remember that science is concerned only, okay.
Oh, Jesus Christ. The computer decided to update itself. I'll use mine. You still have your key?
Perfect.
Sorry.
Thank you. Just scroll down. All right. Sorry about the technical glitch. So we're back. So Dirac was telling, right? At this stage, it becomes important to remember that science is concerned only with observable things, and that we can observe an object only by letting it interact with some outside influence. I think that's very clearly, right, an empiricist sentiment, right, that Dirac is articulated, and seems to be a very sensible one. Of course, we need not be bogged down by the only part, right? Of course, science is concerned with all kinds of things, right? But he said, well, if you want to characterize the very constitution of matter here, a constraint about the observable will play a key role, right? And so he says, an accurate observation is necessarily accompanied by some disturbance of the object observed. So when you observe something, you disturb it, right? Necessarily. Note the modality. We may define an object to be big when the disturbance accompanying our observation of it may be neglected, and small when the disturbance cannot be neglected. This definition is in close agreement with the common meanings of big and small, right? So it's usually assumed that by being careful, we may cut down the disturbance accompanying our observation to any desired extent. The concepts of big and small are then purely relative and refer to the gentleness of our means of observation as well as to the object being described. But what we need, as we saw, is an absolute notion, right? We need something that it's a notion of big and small that is not instrument dependent, right? So it's actually grounded in the properties of the objects themselves. In order to give an absolute meaning to size, such as required for any theory of ultimate structure of matter, we have to assume that there is a limit to the fineness of our powers of observation and the smallness of the accompanying disturbance, a limit which is inherent in the nature of things and can never be surpassed by improved technique or increased skill on the part of the observer. Note what he's saying. So if you need a notion of big and small that is dependent on the nature of things, the properties of the objects that you're talking about, right? Not in your techniques to how to access these properties, right? So it's the nature of things that determines whether the object is small or not, right? Smallness is not an instrument-dependent property that results from our interaction with increasingly more powerful tools of observation. It's an objective feature of the relevant objects. Right? So Dirac tells, if the object under observation is such that the unavoidable limiting disturbance is negligible, then the object is big in the absolute sense, and we may apply classical mechanics to it. If, on the other hand, the limiting disturbance is not negligible, then the object is small in the absolute sense, and we require a new theory for dealing with it, namely quantum mechanics. Right? Now, when we put it all together, we can go back to the way that Dirac was characterizing what quantum mechanics is in the beginning of the book, right? Quantum mechanics may be defined as the application of equations of motion to atomic particles, right? And those atomic particles are characterized as follows. So we have the following. Quantum mechanics is the application of equations of motion to small objects. That is, to objects that by their very nature necessarily will be disturbed when under observation in a way that cannot be neglected. Now, I think now it's very clear that the very characterization of what quantum mechanics is depends on modality, right? In the absolute sense here, right? That he's talking about. So I think the modal character of quantum mechanics should be now transparent, right? Note that in characterizing quantum particles in terms of small objects, Dirac has adopted decided deflationary understanding of objects, right? There's no specification about their ultimate size other than their being small, their nature, constitution, divisibility, including commitment to atomism. So all of those things are left completely open, right? So he's doing some metaphysics here, but a very light-hearted way, right? He's just invoking what the minimal he needs to characterize, the smallness of an object, and so leaving everything else open. And I think that's something to be said for that, right? And in fact, this will bypass a number of philosophical difficulties that a more robust notion of object would just bring, right? And that kind of deflationary account of objects, I think, will jive in very well with the form of modalist empiricist that I'll talk later in the talk. Okay, so that's one sense, right? We need modality just to tell what quantum mechanics is about, right? Now here's a second role that modality plays in quantum mechanics, right? It's central in the theory to specify the states that a quantum system can be in, right? Suppose that we have, indistinguishable quantum particles, right? And we're considering now the sort of exchange that these particles can go on, right? So if the particles are totally symmetric under the interchange of any pair, there are bosons, and they'll satisfy the boson-Einstein statistics. On the other hand, if the particles are totally antisymmetric, they're fermions, right? And satisfy the Fermi-Dirac statistics, right? So here's how, in his lovely book, Sakurai characterized the issue. He says, look, an immediate consequence of the electron being a fermion is that the electron must satisfy Pauli exclusion principle, which states that no two electrons can occupy the same state. This follows because a state like this one is necessarily symmetrical, which is not possible for a fermion, right? So we have the very formulation of a crucial feature of quantum mechanics, Pauli's exclusion principle, is inherently modal, right? The fact that those fermions cannot occupy the same state characterize what the state is and what the corresponding objects ultimately are, right? So the modal content of this description is inalienable, right? Without those, you cannot capture the content of what Pauli's exclusion principle amounts to. So which states are possible is determined by the quantum objects under consideration, which in turn determines the relations that these objects can or cannot enter. So Sakurai says, we see that in the fermion case, it's impossible for both particles to occupy the same state. In the boson case, for 2 out of 3 allowed cats, both particles occupy the same state. And in the classical Maxwell-Boltzmann statistic case, both particles occupy the same state for 2 out of the 4 allowed cats, right? So the modal content, I think, it's manifest, right? The possibility of occupying certain states or not is actually determined by the relevant objects that we are considering, the bosons or fermions, right? Now, these are two roles for modality in quantum mechanics, right? Characterizing what the theory is about, also the characterization of the quantum states, right? So then the question is, what's the source of that modality, right? So, and I think there are at least four possible answers that we can offer here, right? One is conventionalism, right? The source of modality is found on linguistic conventions. A second one, sort of a model theoretic approach, right? The source of modality is found in the models. A third one, essentialism. The source of modality is found in the relevant essences of the object that we are considering. And finally, an empiricist alternative, right? The source of modality is found in the relevant objects, right? I'm going to go over all of them, raise problems for the first 3, and indicate why I think that the last one doesn't face those difficulties. So let's see how that goes, right? So conventionalism, right? The source of modality is found in linguistic conventions. Why is it necessary that bachelors are unmarried? Well, because bachelor means unmarried male, and hence we have that an unmarried male is unmarried. Right? Of course, this approach is inadequate since it needs to assume the necessity of unmarried mayors and married, right? And arguably, the necessity of this statement is not a matter of convention, but of logical truth, if you assume classical logic, right? So that wouldn't go very far. It's similarly unclear that the modalities involving quantum mechanics would be a matter of convention, right? Remember, in direct formulation, if quantum mechanics application of equations of motion to small objects, where those are those that necessarily will be disturbed, right, and when observed in a way that cannot be neglected, it's not a matter of convention about the meaning of the word small, right, that yields the necessities in question, right? So Dirac spent some time setting up, why is it that these are necessary properties of the things under consideration, right? So then the objects that we saw are small and doesn't necessarily will be disturbed when observed in the way that cannot be neglected. These are what these objects are, not the way we use the vocabulary, right? Similarly, if you recall Sakurai's observation about Pauli's exclusion principle, right? No two electrons can occupy the same state, right? Given that what's possible or not for fermions. It's not the case that electrons satisfy the Pauli's exclusion principle due to some linguistic convention, right? The principle describes features that electrons have rather than our linguistic usage. So the satisfaction of Pauli exclusion principle, ultimately results from the necessary symmetry of the relevant state, right? And that's how it should be, not a matter of linguistic usage. Now, of course, there are other forms of conventionalism. You may say, come on, I got the most implausible one, right? Surely the conventionalists can do better than that, right? It's okay. Let's try some better versions and see whether that would improve the situation, right? Some conventionalists will assume that the truth of an axiom, right, including the axioms in mathematical physics, is the result of a conventional decision of taking them to be basic principles, and thus constitutive of certain domains of inquiry. So we need not invoke analyticity here, right? So, okay, we just assume conventionally, okay, these are the axioms of the relevant theory, and that's constitutive of that given domain, and the necessity will follow from those things. But the problem, I think, with this conception is that it fails to take the objectivity of necessity seriously. What is necessary is so independently of us. Right? If fermions cannot be in certain states, it is so given the properties of fermions, rather than the result of adoption of certain principles, even constitutive ones, about them. Right? It's not that, okay, we decided, okay, these are the fermions one, and these are the Boson one, and because we decide to make it so, that's a so, right? And this is just not the way the theory was set up, right? So it's ultimately a matter of the relevant property of the fermions rather than one's decision about the principles that allegedly describe their behavior. Now it's the objects that are imposing the principles, rather the conventions about them that is specifying what these objects are, right? As a result, this proposal ultimately fails to explain the source of modality. In virtue of what are necessary statements necessary? Right? After all, taking something to be necessary or true does not make it true or necessary. And so that form of conventionalism would not work. Of course, traditionally, this form of conventionalism is being applied especially to mathematics, where arguably you say, look, there's nothing involving in the mathematical objects but the specification of these principles. So that's all we need, right? But in physics, it's less clear that that's the case, right? I think there are problems even in the mathematical case, but I'll leave that aside for now. Now, other conventionalists take basic principles to be such that the principles hold come what may, right? They're true under every condition, right? So maybe that would be a better way of formulating the principles at hand, right? And I do think that that's an improvement, right? Because now it looks like we're taking seriously that we're talking about certain objects and what features these objects have, right? And that would move in the right direction of taking the objectivity of necessity seriously, right? But then it's no longer a form of conventionalism, right? Since the necessity of the relevant situation is now not a matter of convention anymore, right? But the result of certain features of the objects that we're considering, that are expressed by the generality of the truth described in them, and by the independence from particular domains, right? So now it looks like we can move in the direction of having some objectivity at the cost of losing conventionalism. So rather than conventionalism here, what we have is something that actually can be closer to what eventually we'll get when we get an empiricist modalism. So I'll return to that later. Okay, so let's consider a third alternative, a second alternative, right? The model theoretic view. So the source of modality is found in the models of the theory, right? That's where we should look for what is it that makes something necessary or not, right? Right, this is what, for example, Frassen suggests, right, in part of his constructive empiricism, right? He says, well, in fact, he identified being an empiricist with denying that there are real modalities in nature, right? He says, well, the modality is a feature of the model rather than of the reality that the model is meant to describe. And in that spirit, he would defend the following view, right? If it's not possible for an object to be both red and green all over, it's because of the model of the color spectrum, which represents wavelengths of the various colors, which represent the wavelength of various colors and invoke no overlap in the model among the corresponding colors. Because the model doesn't allow for the overlap between the wavelengths associated with red and green, well, then it's impossible for those things to overlap, right? But it seems to me that this approach gets the situation exactly backwards, right? The color spectrum, understood as the wavelengths associated with various colors, is a physical situation in the world, right? The lack of overlap among the wavelengths, a physical situation, grounds what the model represents, rather than the other way around, right? So, similarly, being small rather than big is characterized by Dirac. It's not a matter of the models used in quantum mechanics. Rather, these properties of the quantum particles that characterize them. So what von Frassen is doing here, of course, although in the spirit of his empiricism, seems to actually get things backwards, right? So it's not that because things don't hold in the model, they're impossible, right? It's because they don't hold in the world that the model will represent them accordingly. Right? And in that case, similarly in the case of the Pauli exclusion principle, it's a fact about electrons, right? Properly conveyed in the relevant quantum mechanical models, but not determined by the models themselves, right? So it's unclear how a model can be a source of modality. Right? Modality needs to come from somewhere else. Right? Okay, third alternative, essentialism. And so the source of modality is found in the essences, right? So objects have their properties, they have, including their modal properties, because of the kind of objects they are. Right? And as Jonathan Law would specify, the general essence of an object of a certain kind is what it is to be that object. And the object's individual essence is what is to be the individual of the particular kind that the object is. This seems all nice and good, right? But I think in the quantum mechanical case, this approach faces some troubles. Right? First, it's unclear in quantum mechanics whether there are individuals, right? At least on some interpretations of the theory, identity cannot be applied to quantum particles, basically because if you have particles, electrons, and two electrons in a quantum state, you swap them around, that doesn't change the states they're in. So you cannot trace the individuality of these particles, and as a result, it looks like they lack, individuality. So as Weil said, it's Ike and Mike, right? And there's no alibi for an electron. You cannot tell which of them did, right? And that motivates, what sort of a known individual's interpretation of quantum mechanics. Schrödinger, developed that. And then Stephen Friend and Desi Krauss, in their book on identity in physics, developed the formal framework to think about those things. Now, on that interpretation of quantum mechanics, there are no individuals in the field, right? So talk of individual essences, in as much that it requires individuals to have those essences, is incompatible, at least with certain interpretation of quantum mechanics. And presumably, you don't want your metaphysics to just rule out by fiat some plausible interpretations of the theory, right? In principle, we should, be ecumenical, right? So that's one concern, right? It would be very hard to make sense on that conception of individual essences, how certain interpretations of quantum mechanics are even possible. Similarly, talk of general essences is problematic, right? How could it be determined what it is to be an electron without relying on a theory, quantum mechanics, that describes, perhaps equivocally, what is to be such an object? So the worry is, sure, the essence of an object is what it is to be that object. The question is, in the quantum mechanical case, is what it is to be that object. The only answer we have is what the theory tells us, right? Say, okay, an electron, it's something that has a certain mass, a certain charge, allows certain spins, and is that part of the essence of an electron, right? Trouble is when you tie in that way, when the theory changes, or your essence will have to change, right? Presumably that's not something you want to have, right? So is it part of the essence of an electron that it satisfies Pauli's exclusion principle, right? How long how far do we go, right, in specifying what it is to be that object, right? Arguably, you may say something wouldn't be an electron if it violated that principle. Is that enough to put that into the essence of an electron, right? Part of the issue here is our theory of essence is not fine-grained enough to help us answering those questions. And depending on how you answer that question, you get a very different answer as to what the essence of an electron is. Right? So it looks like we have an issue here of informativity. So it's, as a result, it's unclear what explanatory work essences ultimately provide. Right? Specifying the kind of thing that something is simply moves one level up the description of the relevant object. Right? It does not account for the behavior or trace of it any more than the direct description that the object already does. So the question is, okay, how come that talking about essence can help? Right? If all we can do when we specify the essence is what a theory tells us, and we pick out from that theory whatever we think are the essential properties. Right? So why bother with essences then? Right? You say, okay, whatever quantum mechanics tell us about electrons, that's what electrons are, and that's the end of the story. So why bother with essences? The issue is not a matter of legitimacy of using certain expressions, such as essence or kind, but identifying the explanatory power of the certain styles of reasoning. Right? What explanation, what kind of explanatory understanding are we obtaining when we consider essences in this way? Right? That's my concern here. Right? It's unclear what we actually are gaining. Right? It's unclear that an additional form of understanding is offered, and it's not that something behaves in this way because it's an object of a certain kind. Since this seems to add very little to what is already provided by the description of the object in the first place. Right? It's quantum mechanics that tell us, that electrons have certain masses and charges and so on. So why do you need to, on top of that, add talks of essences? Right? It seems gratuitous. An empiricist can, of course, use kinds without refining them by noting that they are just plurals of particular objects, ways of grouping things, right? So if you want to talk about kinds, you may say, look, just don't reify them. I don't think of kinds as capturing something that nature is built into a priori, right? That's a particular metaphysical gloss on what a kind is. And then empiricists say, well, don't do that, right? So think about kinds of just plurals or particulars, right? So you have a bunch of objects that have these properties. Well, so if you understand kind in that way, of course, it's a very deflationary. We can, right? Now, returning to the case example of quantum mechanics, remember the Pauli exclusion principle, right? No two electrons can occupy the same state, given the necessary symmetry involved, right? Now, satisfying Pauli exclusion principle is a consequence of certain modal facts about electrons, and then it's a necessary symmetry of certain states. So rather than essences, it looks like the modality is what accounts for the behavior of electrons, right? So, because in large parts, they are what they are here because of the modal properties, right? What they can or cannot get into certain relations. So again, it looks like modality is what is guiding here rather than the essence, right? So it looks like that, for example, an essentialist view would actually not offer the more basic account of those issues. Now, perhaps a different kind of essentialism could do that, right? Maybe an essential dispositionalism could overcome these difficulties. That's a view that Taco and his collaborators advanced. So here's what they say. According to essential dispositionalism, any electron essentially has a disposition to become modally connected with electrons when a certain condition obtains. And that condition is that they are entangled with other electrons, right? So basically, what we have is, what is essential to an electron is not that it's modally connected with other electrons, but rather it's essential that to an electron that it has a certain disposition to become modally connected with other electrons, right, in an entangled state. So they said, okay, it's that disposition that makes electrons what they are. They are disposed to be entangled with other electrons, right? And so that should be their dispositional essence. So don't think of essence in terms of what the kind of thing that an object is, but think in terms of the disposition that the object may enter into with other objects. All right. Two concerns here, right? First, the proposal is restricted to a certain particular kind of interaction, right? When the condition C is satisfied, and so it's a condition of entanglement, right? With other electrons. But clearly that's just one particular kind of interaction, right? There are other kinds of interactions, right? An electron may be absorbed by a proton in the nucleus of an atom, right? And those interactions also have modal forms. So are they part of the essence of electrons, right? Or these are no, these are just no, this is just a contingent, no essential property. Well, what makes the entanglement the essential one, right? So in a way, the worries about the essence that I was running earlier applied here as well, right? It looks like we're picking and choose certain properties. It's all right, that's essential, that's not. The question is, well, how can we tell, right? What, on the basis of what are those the essential ones? Second, it's unclear what work dispositions are actually doing here, right? If electrons must satisfy Pauli's exclusion principle, this is not because of their disposition to become modally connected with other electrons. It's because of the necessary symmetry of the relevant states. So again, it looks like this, the modality that it's actually forcing them into those interactions rather than the dispositions, right? So once again, it's modality that seems to be more basic than the dispositions that we are involved with, right? In any case, because we need a modality to characterize what these dispositions are, right? Because the modal content of Pauli's exclusion principle is, as I indicated earlier, needed. Okay. So that leaves us with the final alternative, and an empiricist modalism. So the source of modality is found in the relevant objects. Now, as should be clear by now, I've been trying to indicate how that view sort of drops out very naturally from the way in which quantum mechanics is being formulated, from the sorts of features that the theory has. Right? Objects have properties, including modal properties. Right? The table that I have in my office, even this table here, right, is fragile, right? Given the materials that it's made of, right? If an elephant comes here and sits on it, it will break, right? So, and that's a modal property of the table. Right? Now, I'm talking about a modal property of the table. Don't think of that property in a metaphysically robust way, right? And so the modal property here is I'm not saying that this table is breakable because there's a counterpart of it in some other possible world in which it does break, right? In fact, that would be, I think, a misguided way of trying to describe the modal properties of the table. I'm interested in this table rather than the counterpart of it, right? Doesn't matter how similar the counterpart may be of that table, I'm talking about it. I'm talking about, well, it's fragile because of the way in which the table is built, right? The materials that it has and so on. So those are the properties of the table, right? And the same thing you want to say about fermions and bosons, right? They also have modal properties, right? Those that we saw earlier, right? It's impossible for fermions to occupy the same state, whereas possible in some case for bosons you do, right? These are possibilities of impossibilities of the objects in question, right? So I will put modal properties together with whatever other properties that objects have. So they are just more of the same, right? It's just that the objects have those things, right? As we saw, similarly, an electron must satisfy Pauli exclusion principle, right? It cannot occupy the same state because of the necessary symmetry, right? And as we saw also the indirect characterization of quantum mechanics, a small object is understood as those that by their very nature necessarily will be disturbed under observation in a way they cannot be neglected. Those are modal properties of those objects. They're true small, right, in an absolute sense. So any attempt to observe them will require some interaction, and that interaction will disturb the object, right, but given what these objects are. So the modal properties are part of what these things are, right? And these are the, focusing on these properties exactly what quantum mechanics does, right? According to the modalist empiricism, modality, however, is primitive, right? There's no attempt to reduce modal to the known modal, right? Something that I don't think can be done in any case, right? In fact, not even the modal realist is able to do that, right? Lewis says, well, I'm going to spell out what's possible in terms of what's true in some world and what's necessary in terms of truth in every world. And worlds are maximally connected spatial temporal regions, right? So, okay, they're not modal things, so I hereby reduce modality to the known model, right? And then you think about, okay, why is it that in no world I have objects that have contradictory properties, right? Being F and not F, right? Why is that, right? So if you think, the modal realists would say, well, consider the space, the logical space, right, of all possible worlds, right? Well, in none of them you have an object that has those properties and doesn't, right? Why not? Well, it's not possible, right? And of course, that's what we want to say, right? But that notion of possibility is not a world-bound notion because it concerns the very structure of the logical space. So we need even the Lewisian to make sure that the logical space, included only those worlds that are possible. We'll have to assume some primitive modality. Right? So, well, in that case, why bother with a reductive project? Right? Assume modality is a primitive notion. Right? You need that anyway, and run with that. The nice thing is, you can actually, once you have that notion, the primitive notion, you understand that even the notion, for example, of logical consequence it's also a modal notion, right? An argument is valid if and only if it's not possible for the premises and the negation of the conclusion to hold, right? So the notion of consequence is modal. In fact, Aristotle, when first systematized logic, that's exactly the notion he had, right? It's a, an artifact of the modal theoretic view that it makes the notion of consequence not modal. So, well, what's true in every model, right? But the question is, how can we tell the models, set theoretic models, represent all possibilities, right? In fact, I want to say that, if we're talking about what follows from Zermelo-Franco's theory, right, I would like to have in the domain of that theory every set, right? So that we're considering all the sets, but there's no set of all sets, right? So if Zermelo-Franco theory is consistent, right? So I cannot even have a model according to the model theoretic standard that includes all relevant sets, right? So it has limitations in what even that notion can express. So a modalist, empiricist would say, well, take the primitive notion of modality, right, as your starting point. And of course, that's what makes, the view modalist, right? And that's something that Scott Charkowski for a long time pressed, right? The importance of thinking carefully about this primitive modality, and I think he's right about that, right? Note that the modal considerations in quantum mechanics, as I tried to indicate in the first half of the talk, these considerations drop out very naturally, right? From the quantum mechanical domain and the specification of the states of quantum systems. So it's something that just drop out, right? So you don't need to add, sort of special, metaphysical characterizations of that modality, right? So, based Quine and Lewis, modality understood of what's possible or necessary, not what's true in all possible worlds, is not mysterious, right? There's no need to try to, we need to purge our theories from any modal discourse. I think, in fact, that would undermine our attempt to talk about the relevant objects that we're trying to make sense of. Right? And I think that's one of the things that modal realism invites us to do, right? Forces us to think about counterparts rather than the properties of the things as possibility we are interested in understanding. And I do think we do have a sense of what's possible or not. If things hang together or not, we slowly will build up that from there. And now you may say, okay, why is this a form of empiricism, right? So the proposal focuses on properties of objects that can be detected, right, by suitable instruments, without refining such properties. So the idea here is, when I'm talking about properties here, obviously I'm not talking about instantiation of universals, I'm not talking about what happens in a possible world, right? I'm not talking about abstract objects, right? Propositions, or you name it, right? All of those ways of speaking are what I call metaphysical reifications, right? They are ways of spelling out what the nature of the properties ultimately are, right? But the problem is it's unclear that answering the question about the nature of these properties by identifying with certain metaphysical construct actually illuminates what these properties are, right? Well, if I'm interested in say, look, I want to understand the fragility of this table, and you say, well, actually, this is a certain universal that gets instantiated, this position in this game. How that illuminates, right? It looks to me that the fragility is better understood in terms of examining the properties of the table itself, right? And resisted the metaphysical gloss, right? It's the need for reification. Say, okay, I need to identify what kind of object, that property stands for, that invites us to actually try to spell out in a metaphysically robust way the relevant properties. So what the empiricist is offering here is, well, resisting each, you add these additional descriptions, right? Even in terms of dispositions, because they also reify, right? They say, well, there are these dispositions, right? And we run into the same problems, right? Now, as opposed to von Franzen, who insists that we are realists about the observable, and the observable is restricted to what we can see with the naked eye, right? I offer sort of a broader form of empiricism here, right? Because after a pandemic, right, where the world basically stopped because of a virus, it would be very hard to say that, well, I'm agnostic about the existence of viruses because I cannot see them with the naked eye, right? So I want to say that, well, we can actually see those things. In fact, that's what electron microscopes allow us to do. And you can tell a story about ways in which seeing an electron with a microscope is a natural extension of seeing them with our naked eye, right? So our observations have properties, epistemic properties, right? What we see doesn't depend on us, right? On our beliefs, right? In that sense, you open your eyes, what you're going to see is not up to you, right? There is a robustness there. You can refine the access to the object. You can get closer for a better look, right? You can track an object in space and time. If you have nothing better to do, you can keep track of a cockroach for a whole week and see where it goes. And all of those things are epistemic properties that observation has, right? All of them are satisfied by an electron microscope, right? You can't, and this is the result of a counterfactual dependence relation between the sample, that you put in the microscope and the corresponding image. Had the sample been different, the image would have been correspondingly different within the sensitivity range of the microscope. Had the sample been the same, the image would have been correspondingly the same. And because of this counterfactual dependence relation, which observation also satisfies by and large, we can see the ways in which an electron microscope extends naturally the properties of seeing. Right? Now, not every microscope satisfies those properties. Right? Transmission electron microscope, scanning tunneling microscope, the connection between the images, the sample and the images are not so tight. There are too many ways in which the image can be recast that need not track the properties of the sample in a uniform way. So that doesn't mean that they're not tracking anything. Right? It means that, well, I wouldn't say that we are observing things, right, with those kinds of instruments. Right? So there's still a distinction here in the form of empiricism I offer between the observable and the unobservable. Right? I do think, as biologists would say, we're seeing, bacteria, we're seeing viruses with electron microscopes, and I think that's right. Right? In that sense, I'm a realist about those things because they're observable. Right? That's what it is to be an empiricist about them. Right? But there'll be other things that are just too small. About which too small in the absolute sense that Dirac was talking about. Right? And those things, well, okay, I'm going to be agnostic about it. But then there is a reason, right? There is an epistemic reason to be agnostic. And I think that's what a good empiricist would do. Right? So the idea here is that when we think about the modality, there's no reason why the empiricist should move away from the modal discourse. Right? Hale moved away. Right? So, well, look, we can see the constant conjunction of objects, right? But not their necessity. Right? I cannot see the necessity in those things. And of course, mind you, Hume also couldn't see if it blinked while staring at a mirror. He could not say that it's the same after blinking, right? And that's been in part because he had a ridiculously narrow understanding of what experience is. I think experience is a little richer than that, right? And so I do think we can observe certain impossibilities. Right? I can observe that impossibility of me moving this wall by pushing it, right? And I think you can too, right? not every modal property will be observable in this way, right? Some will get to them, out of results from inferences, right? But I think some can and have been observed. So in this way, properties are not meant to be understood in terms of abstract objects, universals, or possible worlds, right? They're just features of things, right? Breakable tables, negatively charged electrons, necessarily symmetric states. These are just, what these properties are, right? Finally, I said that this is a contingency-first approach, right? So, and in a way, I think that's the way the world is for an empiricist, right? The world of an empiricist is a world of contingencies, right? It's actually Sartre's world, right? Where things are just contingent, right? Or if you want to put it in another way, right? Everything is possible, right? That's the genuine empiricist world, right? Well, a world of contingencies, right? That doesn't mean, in saying that everything is possible, that's not saying that everything will happen. Certain possibilities are very unlikely, right? We mark them accordingly, right? Now, how about necessities then? Right? On this view, necessities are always relative, right? It's only if certain things are held facts that others can be held necessary, right? So the necessities are always conditional necessities, right? So in a Newtonian system, mass cannot change with speed. In a relativistic one, it can and does, right? So, is mass dependent on speed? The answer is, well, it depends, right? Depends on the system you're considering, right? If a Newtonian system, it doesn't, and a relativistic one, it does, it can and does, right? And I would say the same thing goes even for mathematics, right? Is it the case that every set can be well ordered? Well, the answer is, well, it depends, right? If the axiom of choice holds, the answer is yes, otherwise it doesn't. So not even in mathematics, there are necessities. I would say not even in logic, right? Even logical principles will hold in certain contexts and fail in others, right? And that's something that happened with various logical principles. That's one of the things that we learned throughout the 20th century with the emergence of a number of non-classical logics, right? And again, this is not of an empiricist, a view about logic. So on this view, what needs to be explained is the necessary. The contingent being ubiquitous need no explanation, right? And but then the necessity is conditional, right? So there are no absolute necessities. And that's how I would avoid the sort of implausibility of trying to explain the necessary in terms of the contingent, which, as I said earlier, looks like a non-starter, right? It looks, if you think that there are absolute necessities, I think that's an illusion, right? At best, we have conditional necessities, right? And those can be accounted for in terms of other contingencies, right? In the way that I indicated. So ultimately, the necessary of a thing is only the assumption that something else holds, right? But this is something that could be otherwise, right? It's ultimately contingent. And that's the way that an empiricist world will go, right? Everything is possible. All right, to conclude, right? I think modality is crucial for quantum mechanics, including the characterization of the quantum domain and the specification of states and quantum system. Right? But the source of modality should not be understood in terms of conventions, models, or essences. Right? Rather, it should be understood in terms of the relevant objects and their properties. And if you understand those things in a metaphysically not substantive way, I think an empiricist can make good sense of those things. Right? In this way, empiricist modalism offers a deflationary account of modality and its source in the context of quantum mechanics. Of course, a lot more needs to be said and can be said about all of this, but I think at least, I hope that this is a view that can be taken seriously. Thank you very much.
So
you very much, Otávio, for a great talk, very clear and very interesting, as always. I'm very sympathetic with your approach. As you know, I'm not a friend of the senses. I'm trying to be an empiricist. But now, since you take a realist posture or stance, then I don't see why you deny the reality of modalities in the sense of dispositions, properties like breakable. Of course, I agree that you don't want to resort to possible worlds and to posit universals or tropes and things like that. But if you want to get a plausible and convincing account of possibility and necessity, I think that you have to attribute some reality to dispositional properties such as breakable. And I was a bit surprised that you said, well, to decide whether an object like a table is breakable, you have to look at the properties of the table, like the material it is made of, and things like that, which are usually taken to be observable properties, and then categorical properties, which is fine with me. I think that dispositional properties are identified as better proposes by their manifestations, which are categorically characterized. So I think that broadly your position, is very, very convincing. But I think that I don't see why you would deny that dispositional properties have some kind of reality, because to grant your main example about the electrons, which are fermions, well, why they cannot be in the same states, because of the real properties of the electrons, and so there is some modality present here, real modality, and these are real dispositional properties in a thin sense.
Good. So I would wish you all the way up to your last point, right? Because I do think they are modal properties, right? The electrons cannot be in those states, right? And at that point, you said, but then you offer a dispositional gloss to this cannot. And that's the part that I don't see what the disposition there, what the disposition is doing there, right? In terms of explaining the modality, right? If anything, I think it will be the other way around. Once you have the modality, well, these things cannot be so and so. Then you could explain the dispositions if you so want, right? But that, I think, it's a metaphysical addition. Because the reason I'm resisting the dispositionalist in part is because some versions of dispositionalism would say, well, it's the disposition that will explain the modality. And that I don't understand. Right? Because, well, it's the fact that the electron cannot be in those states, right? That make it an electron. And then if you want, you can derive dispositional properties that you will have. But that's an added loss, right? And that's the point that I said, okay, now we are adding things, metaphysical descriptions to these objects that I don't see why they are needed.
Right. But you accept that they are modal properties.
Yeah, of course.
Okay, but you don't want to call them dispositions. Okay, so I think that's just a matter of, linguistic expression.
Well, yeah, I think it's a little more because it's a matter of the dispositionalists want to say, well, there are those things, the dispositions, right? And the dispositions are things that, well, under those satisfaction condition, the manifestation would.
No. Better doesn't say that. The dispositions are not identified by stimulus manifestation pair, as you know. They're identified by the manifestations only. They're possibilities, as she says, potentialities. Yeah, exactly. They are modal properties.
Yeah, but then I don't need the dispositions. At that point, I said, well, then I don't see what the work is.
Not dispositions in the sense of the conditional analysis, certainly not.
Right.
Okay. Well,
we'll talk more. Yes, thank you, Michelle.
Yeah, I had more or less the same question.
Okay.
So let me ask another question.
Yeah.
Also very sympathetic to you, and I think it's actually quite close to dispositionalist views, especially because you put the modal properties in in the objects. There's an empiricist gloss added to it, but I think also that is quite present in Letter and others. So yeah, more or less. But what I then want to ask, given that you already responded, is about the specificity of quantum mechanics here, and about what you said in the end about observability and so on. It seems that you could tell us a very similar story about every theory in science we've come up with, where you could have the modal stuff do a lot of work and justify it in a empiricist way. And the kind of features you gave about the two modal aspects that are clearly present in quantum mechanics. I mean, I guess you can come up with things like that in other theories too. But there was something specific about the Dirac idea where to think of small objects as those where there's some impossibility to still observe without disturb, which is interesting, but it's sort of, given the things about observability you said in the end that were sounded very empiricist in an old-fashioned way, that if it doesn't, you don't consider it as anymore as a real object or real property of God if it's not observable. So it seems like that makes you go say that, well, as according to Dirac's criterion, that if we are in the quantum mechanics kind of domain, then actually it's not empiricist anymore. Like we cannot talk about I don't know the typical quantum states and their properties as being modal and real, because we cannot observe it in the sense that they're too small to be observed without being disturbed and so on. So I don't know where the observability here works.
Yes, perfect. No, that's a great point, right? So you're right. You know, Dirac was there talking about observation, right, and observing an electron. I don't think we can observe an electron, right? And in part for the reasons he identified, we disturb when we do it, exactly because we disturb when we try to observe, that we're actually not observing in the way that it will break down the counterfactual relations that I think observation requires. Right? So that doesn't mean that electrons do not exist, right? That's a separate issue, right? The empiricists here will be agnostic, right? Maybe they are, maybe they aren't. That's a separate matter. In fact, according to quantum field theories, there are no electrons, there are no particles, right? So even what are we observing, right? No, situations of fields and something else altogether, right? So So and those are concerns that the empiricists will join in and raise and say, look, we're not saying that electrons do not exist. So the question should be ontologically committed to those things, right? And then I think be agnostic about those things is perfectly appropriate, right? And so that's where the empiricists will draw a line, right?
But you speak about modal properties of objects. Which objects?
Yeah. Look.
If you're agnostic about,
look, here's an example. Sherlock Holmes cannot fly over the Atlantic, even though he doesn't exist, right? Sherlock Holmes is described in the novel as, a man. Properties of humans are such that they are unable to fly over the Atlantic unaided. The fact that an object doesn't exist doesn't mean that it doesn't have modal properties. Of course, he has. Right? I'm not saying that electrons do not exist. I'm being agnostic about that, right? According to some of our best theories, they do not, right? But that's an issue that we can discuss. But we can talk about the modal properties of things independently of whether they exist or not. Those are separate issues, right?
So then there should be something that exists.
Well, I think, there are lots of things that do exist.
No, but for quantum mechanics, that are the objects you don't want to talk about Sherlock Holmes, you want to talk about a quantum system or something, I don't know, something that you observe, right? No?
Well, the question is, because you're forcing me, we need to be realistic about quantum mechanics in order to make sense of the theory. And that's not so clear to me that it's needed, right? Right, so, no, that there is something there, I'm not denying. The question is, what is that is there, right? So, it turns out that really depends on the interpretation you adopt. You have very different descriptions of what it is. So it's unclear what exactly is it that we're going to be realist about if you want to be realist about those things. And the empiricist looking at this will say, look, I'm going to suspend judgment. Right? I don't know what it is that is going on there. There's this description, there is this other one. Each interpretation will indicate how the world could be according to quantum theory, right? But the interpretations are very different, and there's no agreement about that.
There's a lot of questions asked.
Yeah, I mean, I thank you for the great talk. I think I have 8 questions, but I will ask one, and maybe there'll be time for another one. I don't know. But the question is really about the kind of particular versus kind of collective properties of quantum objects. Because you didn't say a lot about entanglement, and some people have said that entanglement is kind of the essential feature of quantum theory. And one way of taking the view, I don't know if you would want to go this way, would be to say that we don't, when we talk about entangled systems, we don't talk about like the separate modal properties of the individual components of the system, but rather now we talk about the like collective modal property of the entangled system. But then if everything is entangled with everything else because it interacted at the Big Bang or something like that, then maybe the entire universe is one entangled system. So really we just have like modal properties of the universe as a whole. Is that somewhere you would be happy to go, or you want to stop before we do that?
Well, I think that's one way you can go, right? But the theory doesn't require you to go that way, right? And often the reason why people go that way is because they're pushing a sort of realist picture, and because they say, well, we need to take the wave function seriously, and so there's the overall structure of the entire universe and the entire history of. And I think when you go that way, then probably going too far, right? Not that it's incoherent to go that way, but I don't think the theory forces you.
So how do we understand then the modal properties of entangled states?
No, I'm happy.
The modal properties of their components.
That's right. I want to say that, yeah, it's a relational property, right? It really depends on the electrons connecting with one another. And I'm happy with that. The question is, do we need to go that, once you get that, now everything else needs to also be entangled? And that bit, I think, you actually added an extra step that I don't see we are required to take.
Okay, there's 3 hands, but now I think my memory is faulty, so you were the last one. Oh no, there's 2 there. Okay, 4 hands. Okay, we'll try to do it in a reasonable time, and I come back to you.
Thanks, I'll be quick. 2 quick questions, Otávio. Thank you so much. First, there was a question about the internal dialectics within the empiricist camps, because you mentioned at the beginning you wanted to broaden a bit your horizon on the conception of experience. So you said a lot about the relative merits of empiricism with regard to conventionalist, model theoretic, or essentialist alternatives. I was wondering, what about the empiricist camps? Relatedly, a lot depends on how we unpack this notion and this criterion of observability. I think this was also one of the crux in the debate about scientific realism. And that kind of criterion came a lot under pressure. So I was wondering whether you can say a little bit more about what kind of a criterion of observability you actually have in mind.
Okay, perfect. So the 2 are connected, right? Because what is observable, right? The way that I formulate is what satisfies the counterfactual dependence relation between the scene before our eyes and the visual experiences that we have, right? Had I still had hair, right? There was one, believe me, there was a time in which I did have hair, right? As much has as all had, right? Long hair, I love my hair, right? So, and then I didn't follow the advice that I tell all my students, don't get old. So now the hair is gone. If I still had the hair, you would see it, right? But I don't, so you don't, right? So there is a counterfactual dependence between the scene before your eyes and your visual experience, right? And that counterfactual dependence, again, don't think of that counterfactual in terms of possible worlds. It's changing in the world, right? My hair is not being there anymore, and your experience of me is one of a hairless creature, right? At least I'm no longer a vague object. I'm definitely bald now, right? So that's what I think makes observation, right? So, and I would, as I mentioned, I would extend that with aided observation. So because with certain instruments, we can have that counterfactual dependence relation being met, right? And if you have the grounds to think that those relations are met, well, then we are seeing with an electron microscope, for example, right? And because these are features of experience, the experience is also, and that addresses your first question, now more broadly understood, right? Because it includes not only the phenomenology that we have when you're seeing things just with our naked eye, right? Being sensitive and tracking objects, right? In the way that the counterfactual relations with the seen before eyes allow for, but also with the experiences we can have with aided instruments, right? That's also, it's a form of experience. And because it has the same structural epistemic features that experience without the instruments, right? Then you have a broader notion of experience, right? And then we can see, I think you're being a perfectly good empiricist when you say you're observing, microchromium, right? Or you're observing viruses through an electron microscope, right? So it's a richer understanding of experience. But I don't see it as being any more empiricist, right? It's just that we are not just suckling the empiricist with a radically impoverished understanding of what experience is. If you do that, then sure, the view becomes very implausible.
Yeah, thank you very much. I was wondering how you can just ignore the Humeans. So the issue here, and that I think already came up in the second question, is that it's not, you're talking about quantum mechanics, but exactly the same issue is going to arise for any theory of the motion of objects and propagation of waves. Is that any scientific theory, any physical theory is going to admit certain possibilities and rule out other ones, restrict us to a certain region of a configuration space. And for any theory, the question is going to arise here. So it incorporates the notion of necessity and possibility. What's the nature of this notion of necessity and possibility that we get from a physical theory? But that's just the old question of what's the nature of nomic necessity. And clearly, all the views that you discussed, but how about Humeans? People who just have a regularity view, a sophisticated regularity view. Yeah, I'm not saying that you ought to have that view, but you can completely ignore that way of making sense of nomic necessity. I was just wondering whether there's anything more we can say about that.
Good. Yeah, no, that's a perfectly good question. And I'm actually sympathetic with that view. I don't think there are laws in the sense that if laws require some kind of necessity, because I think that, for the reasons I tried to indicate, the best you get at those contingent conditional necessities. So we don't have bona fide laws as such. But we do have regularities, right? And some of them are fairly stable, right? And the sun will rise tomorrow. Well, that's very likely. And there will be one day it won't. In fact, it will explode, right? So, and we have good theorizing about that, right? And so that there will be regularities, right? There won't. If you want to call these things laws, it'll be my guess, right? So, but I do think that they don't have the sort of absolute necessities that some more robust accounts of laws will have, right? So I think in the spirit, with the Humeans in that, the question is, do I need to add a thing to the fact that, look, and there's nothing else there that you can add, right? And that would be something that I would say, well, I don't know. You can try to add. It's not that it's incoherent to add, right? Something else to those descriptions of these regularities, right? And it's not required for understanding of scientific practice and other things, right? Presumably the human is saying, the stuff that the non-human is adding is uncalled for, and those things do not exist, right? So that's an added metaphysical addition that they have. And I would say, look, I just don't need those things. Maybe they exist, maybe they don't, right? Or we're just agnostic about that. And if that's what they mean, okay, then I think we're on the same on the same boat.
Jonas?
Well, thank you very much. So I have a question. It seems to me that you may be confronted to some sort of beautiful problem at some point. So at one point you said that we have symmetries, and symmetries entail necessary entangled properties. And at the same time, you say, okay, we have the properties, and one might argue that they are dispositionally such that they could be entangled. But you said this is because the explanation is the symmetries. And you say, okay, the symmetries explain why the particles are entangled. And here you could go like Tim Williamson and say, okay, we have the necessary equivalence. Why should we make an hyperintentional distinction and say we have the properties and they are more fundamental than the symmetry? But you don't say that. You say, in fact, it is the symmetries which are the more fundamental. I mean, the symmetries will explain why particles are entangled. So I was really wondering why you should, what you appeal to the symmetry, which appears to be like the more general relation, to explain the entangled objects. Because here we may have this beautiful problem. Why say this and not the other way around? I'm not sure I understand.
Well, it's not me who are saying, it's the physics, right? So I'm just following the way in which quantum mechanics has been designed, right, and characterized. So you have these, antisymmetric properties, and out of those, you get the electrons. So to do the reverse seems to me, we're doing that out of philosophical motivations. And I say, why should you do that? Right? It's nothing that calls you other than a particular philosophical picture that you want to have. And then I see, well, I don't need that. I'm trying to make sense of the theory. The theory can go just on one way. So we don't need to do the other way.
Yeah, but this is very scientific.
But as an empiricist, if it goes the way later, you would say, okay, let's go in the direction of you. You follow the science as an empiricist. You don't follow the metaphysical.
Yeah, but look, not blindly, right? It's, Dirac was talking about observing electrons. And I said, well, we cannot observe an electron, right? So it's not that, okay, anything that the science says, okay, we just use that to settle. That there are philosophical issues that sometimes are put in, right? So what I'll try to resist is the need to add something, right, that may not actually explain what we're trying to understand.
Last question.
Thanks, that was really interesting. I have two, but they're really simple ideas. So I think that the way in which you criticize both the conventionalists and essentialists, I think it's perfectly fine, but at the same time, I think that they would say, yeah, that's why we believe. That's why we are conventionalists or essentialists, right? So they would take this as a rather advantages of their accounts than disadvantages, right? Because, well, let's take essentialists and the assumption that, well, water is H2O, water is essentially H2O, right? So would you tend to say that, well, that's kind of that shouldn't be the case because you need to have modern chemistry to establish that water is H2O, hence you're in this vicious circle, so to speak, because you don't know what you're looking for without theory that tells you what is the essence of an object, right? So would you say that this criticism applies not only to the essentials when it comes to quantum mechanics, but essentials like in general, or is it just against applying this to quantum mechanics? And the second one is, well, so what are properties? I mean, you did say that. I mean, I wasn't sure you were saying that. Well, I don't care what they are. Whatever your favorite notion of properties is that should work well, or it's kind of a primitivist about properties as well. Right?
Good, great questions. So, yeah, on the essentialism, I do have worries about essentialism, beyond the case that I discuss here. And they, by and large, are concerns about the explanatory power of essentialism, right? So it looks like to the extent that we can illuminate what these objects are, it's not by telling, okay, these are the essences, right? Well, I need to know what these objects that we're trying to understand. And once I know that, well, that's it, right? So I don't need an extra. Say, okay, well, by the way, these are the essences, not these other things. In part because often we can redescribe things and then change, and so well, now it looks like the essence is something else, right? And I'm not clear that the essentialist is really advancing in helping us understand what the objects are in the end. So I do have, more broadly concerns about it, right? And about the properties, I do think we need to start somewhere, right? So I've been assuming objects and properties, right? And modal properties are among the properties that these objects have, right? I do think that we need a distinction between object and property, right? Without that, we cannot make sense of predication, right? Without predication, we cannot make sense of consequence relation. So that I think is a very basic distinction. I do think anyone has to have such a distinction. What is a property? So when you ask that question and say, well, now you're asking me, right, to reify this thing and offering you a metaphysical account, right? It's unclear that the metaphysical accounts of properties really illuminates properties beyond the fact that, well, there are features that things have, right? And often I know what these features are by interacting with the objects, right? If they are concrete objects or if they are abstract objects, by reasoning about them and see what follows from there with the relation with other concepts. And so do I need also to say, okay, this is, properties are universals or tropes or whatever is your favorite theory. It's unclear that offering that metaphysical gloss actually illuminates what these properties are. So it's not that I would say, well, pick and choose, right? I would say, well, don't. I don't think any of those actually illuminates, right? Understand the objects, because that's what we're trying to make sense of, and the properties, right? So it's a very minimal account. But it's an account that I think everybody needs, right? I don't see, even structuralists would say, no, there are structures. Even they would require a distinction between objects and properties. Right? Otherwise, they cannot even make sense of what a structure ultimately amounts to.
So let's thank our speaker.